At 01:47 hours, Ukrainian drone operators at a forward launch site prepared to strike the Kirishi oil refinery, located 1,000 kilometers away in Russia's Leningrad region. This single facility processes 6% of Russia's oil output. Within 3 hours, it would process zero. At precisely 0200 hours, the lead operator initiated the launch sequence from inside his moving vehicle. The first FP-1 accelerated down its rail wings, flexing under load, achieving liftoff at 80 kilometers per hour. Every 15 seconds, another drone followed, banking northeast toward Russian territory. The operators were already 2 kilometers away, racing through forest roads with headlights off, guided only by night vision equipment. Behind them, the empty launch site awaited the inevitable Russian counterstrike. Across Ukraine, the same urgent sequence repeated at dozens of positions. Farm fields in Sumy, where operators launch from concealed bunkers. Highway rest stops near Chernobyl, where trucks revealed hidden rails. Factory rooftops in Kharkiv, where maintenance crews were actually drone teams. 361 drones launched in precisely timed coordination. The tactical coordination proved remarkable in execution. The Kirishi strike package was actually launching last, despite having the furthest distance to fly. These drones burned more fuel flying faster at 200 kilometers per hour, while drones heading to closer targets cruised efficiently at 150. This backward planning ensured all 361 would arrive within the same 20-minute window. Moscow, Bryansk, Smolensk, Rostov, Kirishi all would face attacks simultaneously. Russian air defense commanders would face impossible choices. What happened next would prove why their entire defense doctrine had been designed to fail. Russian podlet radars in temporarily occupied Donetsk detected the launches within seconds. These radars can track a baseball at 60 kilometers. 35 drones climbing appeared as fireworks on their screens. The data flowed instantly into Russia's integrated air defense network. Computers in Moscow began calculating intercept solutions. Fighter pilots across western Russia scrambled to their aircraft, but they were about to discover their entire defense doctrine had a fatal flaw. Russia built their air defense to counter American B-2 bombers, valued at $2 billion. Their S-400 missiles cost $5 million each. Their fighters burned $10,000 of fuel per hour. But these FP-1 drones cost just $50,000 to build. The economic calculus was shattering Russian doctrine. Fire a $5 million missile at a $50,000 drone. Let it through and risk a $1 billion refinery. Every option resulted in losses. Compound that with the fact that the FP-1 navigates using systems that cannot be fooled. The primary receiver tracks both GPS and GLONASS satellites simultaneously. If American satellites say you're here, but Russian satellites say you're there, the drone knows someone is lying. The ingenious element is the backup terrain contour matching. The drone's radar altimeter constantly measures ground elevation, comparing it against stored topographic maps. Even with both satellite systems jammed, the drone reads the shape of the Earth itself to determine its exact position. The engine powering this weapon, a Chinese 2-stroke engine available online for $500. It produces 6.5 horsepower burning regular gasoline, delivering exactly 1,600 kilometers range. Ukraine did not develop exotic military technology. They took hobby shop parts and transformed them into strategic weapons. The warhead, however, was military grade. 80 kilograms of tetryl explosive, detonating at 7,900 meters per second, surrounded by steel balls, capable of punching through concrete at 200 meters. By 02:15, the strike packages had merged into one massive swarm heading east. Russian radar screens displayed 361 contacts, converging on dozens of targets. The question was not whether Russia would detect them. They already had. The question was whether they could stop them. At 02:45, the Kirishi package reached the Belarusian border. The main swarm of 326 drones continued eastward, toward Moscow and other secondary targets. This was the critical moment. 35 drones peeled north, threading between Belarusian defenses and Russian interceptors. If detected now isolated from the main swarm, they would become easy prey. The package immediately split into what Ukraine designates a ladder formation. The Mugen 5 decoys climbed to 3,000 meters, deliberately broadcasting on known drone control frequencies. They intended to be seen, tracked, and engaged. These modified commercial drones even carried radar reflectors, aluminum corner cubes that made them appear massive on radar screens. At $30,000 each, their mission was to absorb fire and save the strike. The UJ-22s leveled at 1,500 meters, taking the middle tier. Some carried real 20-kilogram warheads, others just ballast to match flight characteristics. Their role: absorb missiles from Buk and Tor systems directly, forcing the Russians to exhaust their ammunition. The FP-1 strikers dove to 50 meters, disappearing into what radar operators call ground clutter. At this altitude, radar beams bounce off everything: trees, buildings, vehicles, creating electronic noise that conceals small targets. Additionally, Earth's curvature assists. Radar travels in straight lines, but the planet curves away. At 50 meters altitude, a drone vanishes from ground radar beyond 30 kilometers. Physics itself was shielding them. This is why this formation proved tactically brilliant. Each altitude band defeated a different Russian defense layer. High-altitude Mugen 5S would trigger the S-400s and S-300s, strategic systems designed for bombers. Middle-altitude UJ-22s would draw fire from tactical systems. The low FP-1s would slip through the gap between these layers. And vertical spacing meant no single missile could engage multiple drones. A missile climbing at 3,000 meters cannot simultaneously hit something at 50 meters. Belarusian MiG-31 interceptors scrambled from Baranovichi Air Base. Their Zaslon M radars are among the most powerful ever, fitted to fighters designed to track B-52 bombers at 300 kilometers. But that power became a weakness. The radar uses narrow pencil beams, optimized for high-altitude searches. Trying to find tiny drones at treetop level with a MiG-31 is like using a sniper scope to swat mosquitoes. The pilots locked onto the high Mugen 5s immediately, but doctrine required visual identification before engagement. By the time they confirmed hostile intent, the real strike package had opened a 40-kilometer gap. The decoys were working perfectly, pulling interceptors high while strikers slipped through low. But the drones had just entered the densest air defense network on Earth. Ahead waited the S-300 battery near Tikhvin, with its formidable cheese grater radar. What Ukraine knew that the Russians did not was that this seemingly unstoppable radar had exactly one weakness. At 0400, the package approached Tikhvin, 200 kilometers from Kirishi. The S-300's 9 S-19M2 radar, known as the cheese grater, began tracking them. This radar appeared unbeatable. Its frequency hops across the X-band 100 times per second. 8 gigahertz 12, 10 9. Never the same frequency twice. You cannot jam it because by the time you react, it has already moved. But Ukraine discovered its fatal flaw. During previous strikes every 10 seconds, the system must recalibrate its frequency hopping sequence. For exactly 500 milliseconds, it stops transmitting. Half a second of blindness every 10 seconds. If you knew when that happened, you could disappear. One Mugen 5 climbed to 5,000 meters, deliberately triggering the radar. The S-300 engaged immediately. A $3 million C-9M82M missile against a $50,000 drone. But in the 2 seconds before impact, the doomed drone transmitted the radar's timing pattern to the swarm. Its destruction provided the synchronization data they desperately needed. 27 seconds later, when the radar entered its reset gap, the remaining drones dove to 10 meters altitude for half a second. They were invisible. When the radar resumed, they had vanished into ground clutter. The operators saw ghost returns, possibly birds, possibly atmospheric anomalies. Without solid tracks, they could not engage. The swarm had slipped through during the blindness window. But they had just entered Russia's electronic warfare zone, where GPS itself would betray them. The Pol-21 system activated using a technique called beaconing, recording real GPS signals and rebroadcasting them with delays. The drone's receivers showed them over empty fields when they were actually over cities. 5 minutes of position data, all false. But to use a familiar phrase, it was barely a scratch. The FP1 switched to backup navigation, magnetic heading combined with counting power line crossings. Each major transmission line between the border and Kirishi served as a waypoint, 7 lines total, following the Moscow-Petersburg energy corridor. The drones were literally navigating by counting infrastructure that could not move or be spoofed. 2 drones flew over an iron ore deposit. That pulled their compasses 30 degrees off course. 3 more followed the wrong power lines toward Finland. But the lead drone's power line count matched expectations. It was on course for Kirishi. The package now down to 24. Drones pressed on through thickening morning fog, toward the refinery's glow on the horizon. At 0600, Kirishi's lights became visible, a glowing industrial complex that never slept. 4 Panzer batteries protected it, positioned for overlapping coverage. The 20 remaining UJ-22s split into 5 groups of 4, each group targeting a different Panzer. The operators watching their radar screens faced an impossible choice. Their systems could track all 20 drones, but each battery could only engage 4. Those 4 missiles would need 15 seconds to reach their targets. During those 15 seconds, they could not engage anything else without abandoning missiles already in flight. Ukraine had turned the Panzer's precision into its weakness. Ski missiles launched simultaneously, their rocket motors lighting up the pre-dawn sky like an artificial sunrise. The UJ-22s started evasive maneuvers, but against missiles pulling 30G turns. Physics favored the interceptors, while UJ-22s went down in spectacular fireballs. Their sacrifice bought precious seconds. Because while those missiles flew their 15-second journeys, while the Panzers were blind to new threats, the FP-1 Strykers sprinted through the gap. By the time the missiles impacted, the Strykers were inside minimum range. The Panzers needed 45 seconds to reload. The FP-1s needed only 30 seconds to reach cannon range. The math favored the attackers. The Panzers switched to their twin 30mm cannons, firing ahead ammunition shells containing 360 tungsten sub-projectiles. The fire control computer calculated where each drone would be, when shells arrived creating clouds along predicted flight paths. But Ukraine had programmed random altitude changes every 2 seconds. Up 10 meters, down 5. Up 3, down 8. No pattern for the computer to learn. The predictive targeting was firing at where drones should be, not where they were. 3 FP-1s flew into tungsten clouds and disintegrated. Another caught the edge, half its wing gone, but somehow still flying, the gyroscope compensating frantically. 6 FP-1s cleared the cannon envelope at 500 meters from the refinery. The Panzers could not depress their guns any lower, without hitting their own positions. They had broken through the main defense. But the Russians had deployed a new, specialized system for exactly this scenario. 3 survivors crossed the refinery perimeter at 06:18, but they had just entered the Derivatsia PVO's engagement zone, Russia's newest close-in weapon system, mounted on a modified BMP-3 chassis near the main gate. Its 57mm autocannon was already tracking the incoming drones. This was not just another anti-aircraft gun. It was specifically designed to counter drone swarms like this one. The PVO fires shells with programmable fuses. Here is what makes it lethal. A laser rangefinder measures exact distance to each target, then programs every shell as it leaves the barrel. Each shell counts rotations in flight, detonating at precisely the calculated distance, not on impact but in front of the target. Each explosion spreads 200 tungsten balls in a 10-meter sphere. The drone flies into a wall of metal it never saw coming. The system's computer was already calculating a firing solution called barrage mode. It would create overlapping spheres of tungsten at different distances: 300 meters, 250 meters, 200 meters, 150 meters, a 3-dimensional grid that nothing could fly through. The gun barrel began to elevate, targeting the lead drone at 200 meters altitude. But the PVO's designers had built in a fatal safety protocol. Below 100 meters altitude, the tungsten spheres could hit the refinery. Storage tanks would rupture. Volatile chemicals would leak. The system trying to protect the facility could trigger the exact disaster it was meant to prevent. The safety lockout was hard-coded into the fire control computer. No manual override even in combat. The PVO opened fire at 06:17. The first shell detonated 200 meters from the lead drone, too far to cause damage but close enough to reveal the pattern. The second shell exploded at 180 meters. The computer was walking its fire closer. The third would be perfect. The lead FP-1 tried to dive, but its damage controls responded slowly. The third shell detonated 8 meters away. 200 tungsten balls expanded outward at 1,500 meters per second. The drone's plywood frame shredded instantly. Fuel tank punctured, engine torn from its mounts. It cartwheeled through the air, spreading debris over the refinery. The second drone reached 120 meters altitude. The PVO's barrel tracked downward, following perfectly. At 110 meters, still firing. At 105 meters, one more shell left in the barrel. At 100 meters exactly, the system stopped. The barrel froze in position. The final shell detonated harmlessly above the diving drone. The operator could see them clearly, track them perfectly, but the system would not fire. He tried manual override, denied. He tried switching to direct fire mode, locked out. The computer had decided protecting the refinery from friendly fire outweighed stopping 2 drones, a critical mistake. At 06:19 hours, the first FP-1 struck the CDU-100 junction, exactly where intelligence indicated. 25 kilograms of tetrol detonated at 7,900 meters per second, creating 100 psi overpressure. The corroded supports failed instantly. Crude oil at 380 degrees Celsius and 30 atmospheres pressure erupted from ruptured lines. The superheated liquid hit air and vaporized. A fuel-air explosion propagated through the entire complex. 10 seconds later, the second drone hit Tank 47's degraded seal. The accumulated vapors ignited instantly. The floating roof became a 50-ton projectile, launched 200 meters by expanding gases, before crushing the administration building. 80,000 barrels of petroleum now had no cover, feeding an exponentially growing inferno that climbed toward the clouds. The CDU-100 failure cascaded through interconnected systems, like dominoes designed to fall. The fractionator column, starved of feed, experienced catastrophic pressure drop. Liquid hydrocarbons at 380 degrees underwent instantaneous phase change, a boiling liquid expanding vapor explosion. The column itself, 40 meters tall, split at weld seams. The top section flew 800 meters like a giant missile. Secondary explosions ripped outward. The Belev's shockwave punctured 6 storage tanks simultaneously. Emergency systems tried isolating sections, but the damage was too widespread. Pumps could not stop with downstream pressure gone. Valves could not close against backward flow. The sprinkler system had no pressure. Water mains severed by the first explosion. The Kirishi refinery, 355,000 barrels per day. 6.4% of Russia's capacity was destroying itself from within. Satellite imagery confirmed what Russia denied for days. CDU-100 destroyed, catalytic cracker destroyed. 6 months minimum before partial operations. Full capacity might never return. Russia claimed complete interception of all drones. The inferno visible from space told the real story.